Okay, so our first speaker is Jakob Smekol. Jakob is joining us from, let's bring him up to the stream here. Hi, Jakob. Thanks for joining us.
Thanks for the opportunity to speak today.
Cool. Go for it.
All right, let me share my screen. Hopefully this is going to work. Yes. Can you see my screen? Okay, great. So hi everyone, I'm Jakub, and today I'm going to give a very brief overview of some projects that we've been developing at the Active Inference Institute and their relevance to decentralized AI. Now, I think my talk and Alex's right after me is going to overlap slightly. So I'm going to try to keep the theory of active inference and one particular project to a minimum, although I'll try to give some brief introduction to what active inference is so that you have the relevant background. So since this is a mini conference on decentralized AI, I'm going to assume that most of you have at least heard of reinforcement learning, which on the computational side is quite similar to active inference, but we can think of active inference as being a kind of generalization of reinforcement learning where agents interact with their environment and try to solve a certain task or try to navigate in their environment. But instead of maximizing some utility function or instead of their goal being always maximizing for reward, active inference agents are perhaps more general, where the kind of utility function or the general function of active inference agents is always uncertainty minimization. So active inference agents form some kind of internal model of their environment, and they can learn more about their environment by engaging with it through action and then observing what kind of sensory input goes from the environment to the agents. So there's a kind of duality between perception and action that's always mediated through uncertainty minimization. And because of its generality, this framework can be applied to pretty much any system that's salient enough to persist through time, which was kind of the motivation for the first project, which Alex will talk about a bit more, so I'm only going to mention it briefly, which is the Active Entity Ontology for Science, which really stands at the intersection of three fields, namely DeSci, systems engineering, and active inference, where our aim was to create an ontology that individuals and communities within DeSci can use to collectively minimize their uncertainty about what kind of system they find themselves in and how that system might evolve through time. And I think this is the same can be done for decentralized AI, which has a lot of similar artifacts that have to do with Web3. And perhaps we can say that either DeSci is encapsulated within decentralized AI or the other way around, depending on which you think is the bigger set. But the core utility of having a shared ontology that's kind of grounded in another formal framework, namely active inference, allows us to more specifically define what kind of entities and artifacts we can find in a system and how these entities interact with each other and minimize their uncertainty, so we can kind of have a better understanding of the dynamics of our system and be able to better make decisions about what kind of protocols we should create or how should our community interact with other communities and so on. This also leads me to the active BlockFriends project, which is kind of on the computational side of EOS, where we aim to combine the open source framework CADCAD, which was developed by BlockScience, and that's been used mainly for token engineering and also just generalized dynamical systems modeling, where you usually take a kind of structural top-down approach to modeling your system of interest, where you define your state space and then you perform giant parameter sweeps to try to figure out how your state space evolves through time and what kind of edge cases can you get to, and combining that with active inference, cognitive modeling, where you have agents that have kind of emergent properties that through collective interaction form these communities that themselves can be cast as agents within some environment. So you have this bottom-up emergent behavior through agents interacting and trying to minimize their uncertainty, as well as a kind of top-down parameter sweep over all the possible states in your system. This might sound a little abstract, but I think it's quite relevant for decentralized AI, and mainly for two different reasons. One of them is we want to create different communities and protocols for both co-owning or creating AI models or interacting with AI models, and that's already a quite large state space. So it would definitely be different as a framework to talk more rigorously about AI alignment, which is also a very big question big problem in AI, where you're basically trying to align uncertainty minimization across different types of agents, as well as different levels of your system, where DAOs want to minimize their uncertainty with respect to other DAOs or with respect to some preset goal. But individuals within those DAOs also need to minimize their uncertainty based on their own preferences, which may or may not align with those of the higher level system. And the same can be said of AI models and autonomous agents, which are definitely becoming more present in the digital space. So that would be a very brief overview of some of the projects that we're developing at the Active Inference Institute. And if you have any questions, then I'm not sure whether we have the time, but thanks a lot for your attention.
Yeah, you have about a minute, so maybe we'll save them for a little bit later, unless they're quite quick. Okay, I'm not seeing any text questions yet, so I'll definitely invite people to ask you any questions that they have about that, either in the 10-minute session or towards the end when we finish. Got about a minute now, so I will thank you very much for that. Very cool to hear what you're doing. I'll bring up your colleague, Alex Ryatkin now. Hi, Alex, how are you?
Yeah, fine, thanks. Hi, everyone.
Right. Cool, take it away.
Okay, let me share my screen. Can you see it, right? Okay. So I will add some information about active inference and EOS and continue to Jakub talk, but also will provide more information from institute scale about our work and possible collaboration with our participants. We are an institute which is working on the frontier of active inference, as we consider it, and it's a scale-free cognitive framework, which is based on first principles that models decision-making processes and actions of agents in the environment. And it's quite important about scale-free here, because it means that we can apply it for different types of agents and systems. And for me personally, very important that it's based on first principles, starting from physics, from thermodynamics, through information theory to quantum information theory. It's quite broad space for people who like math and physics. This framework combines perception, action, and inference to optimize information processing and handle uncertainty. In relation to different kinds of agents, it can be applied, which was mentioned for robotics, for artificial intelligence, but also a lot of our fields and domains like neuroscience. And for now, we see real world examples of application of the framework. Active inference agent acting to minimize his surprises in informational sense and maximize expected outcomes on different time scales, having his generative model in place and updating it or updating environment. This process always based on gathering information and based on it generating actions based on that generative probabilistic models. As I mentioned, it's could be applied for various fields, and we are, as an institute, starting it from ourselves in the beginning, from team communications, and later we see paths to decision-making, management, governance, and a lot of other things related to organizations as entities and as agents. As for active entity ontology for science, first of all, we could consider, in terms of active inference, we can consider it as a part of a shared generative model of people as personalities or organizations or projects, which should have some common language in place. And having it, there are some evolution happening and providing ways to represent different scientific knowledges in a common way to enable efficient collaborations and knowledge sharing. It can facilitate interoperability across different scientific domains, standardized concept and relationships. And finally, it could be a way to accelerate scientific discoveries and interdisciplinary collaborations. You can find some additional information and actually paper by these links, and the ontology as itself you can find on Coda page. Maybe have a look and consider if it connects with you in some way. And important here that how it could be developed, both active inference as a framework, as a cornerstone, and in developments with active inference ontology, active entity ontology can improve decision making and collaboration of teams, of organizations. There are possible ways and different ways to integrate it with blockchain standards, which enhanced digitalizations of such scientific artifacts, which later in evolutionary manner could be reproduced and evolved throughout different communities. Finally, we consider Institute as a part of research ecosystem, and our intentions here to provide as an agent to provide more interfaces and more structured ways to communicate in these frontier domains because it's quite hard science, and we need to find ways to use common language in different projects, and by that evolve research ecosystems. So I think that's all from my side.
All right. Well, thank you very much, Alex. That was really cool.
Thank you.
Yeah, appreciate it. Okay. So next up, I would like to introduce, in a minute, David Benarsh. David is the co-founder and CEO of Valerie, the startup that created Autonomous and the Autonomous DAO, and the host of this conference. So let me bring up David now. Martin, I will start this question, and hopefully we can I'll either let Alex answer it in the chat if he likes, or we can have a longer discussion later, but I'm going to start that for now. Cool. So I will bring up David now. Hi, David.
Hey, can you hear me?
Yeah.
Okay, perfect. Let's get started. Thanks, everyone, for being here. Big pleasure. Already we had 2 very exciting talks. I'm looking forward to the other 6 following me. I will be talking about Autonomous, and specifically about autonomous agents and the path to co-owned AIs as we see it. Let's look at some problems. Building decentralized autonomous apps is impossible. At least that's what we're saying here. It is definitely very hard. If you look around, there's very few DAOs and on-chain protocols which are actually fully decentralized and autonomous. So there's some way to go. Actually, with Autonomous, we can fix that. And that's sort of our part of our North Star, helping DAOs become more autonomous and decentralized. But today, I first want to talk about autonomous agents because the whole thing is very connected. And I hope by kind of sharing with you our viewpoint that will kind of be very fruitful, as Thomas said at the introduction, and lead to exciting new things which we're building together. So I've been in the autonomous agent space since roughly 4.5 years. The autonomous agent space is definitely much, much older than that, decades, if you look at multi-agent system literature. And what's quite interesting is that there were recently I'm stretching this a bit, so in the last 10 years, there were 2 big unlocks. First, we had smart contracting chains arrive, and what they brought is sort of permissionless contracting and transacting, which obviously for humans is great, and we've seen that, but particularly for machines is great as well, because it allows machines to much more easily interact, exchange value, create value, etc. But from my own experience, I would say that autonomous agents really didn't live up to their potential with just that unlock. A second unlock was needed, and I'm sure I'll get pushback on calling this better thinking tools because they're much more than that. But that's sort of how I loosely refer to them at the moment. LLMs and other types of architectures which allow you to do similar advanced forms of AI, they basically level up what you can do with an autonomous agent. Now, autonomous agents are great when you want to basically give an intent to a software system or want to instruct it to achieve a certain outcome. But they have one shortcoming from the perspective of looking at it from, let's say, a DAO or a on-chain organization which aims to be decentralized, or a off-chain organization which aims to be decentralized. And that is that they are by design not decentralized. I mean, I can have many of them, and create a system, and we'll talk about this in a second, which ends up being decentralized. But any given single agent, runs somewhere, and unless this underlying substrate is fully decentralized, then it ain't. And to this day, we don't really have these substrates where the entire autonomous system can run on it continuously. Because if we look on chain, having a smart contract represent an autonomous agent doesn't make it fully autonomous. It can only run when it receives transaction. That already limits its autonomy. So Autonomous was thinking about, or the idea behind Autonomous was thinking about how can we make autonomous agents basically decentralized. And the outcome is what we call autonomous services. They can, like autonomous agents, take data from anywhere, be it on-chain or off-chain with 2 APIs, or structured on-chain data, consume it, do arbitrarily difficult things as they're application specific. It really depends on the developer what they do, and then take action on-chain, or again on an off-chain API. And so this is then giving rise to this ability to have basically decentralized agent. And now the exciting thing is we can connect these systems. And so we can have services and agents communicate with each other. Obviously, not just autonomous services and agents. That's kind of the point of our event here, is to make many of these kind of systems interoperate more easily. Currently in our stack, the way you would do this is with something called the Agent Communication Network, or short ACN, which allows the agents to basically communicate with each other purely based on messages, where the basically target is always a wallet address. And so an agent only needs to know its destination's wallet address. It doesn't need to know where in the wide internet they're located, at which IP address, etc. So I've kind of so far walked you through agents, autonomous services, which are these decentralized agents, and the fact that you can connect them in our stack. I want to talk a bit more about how this kind of fits into the larger space. So very importantly, I mentioned this at the beginning, we have these new tools. There's many of them. I've put 3 logos here. Some of them are open source or mixed mode. Some of them are closed source. Some of them are powerful. Some of them are less powerful. They're all very useful tools. And I think we have a couple of talks following which talk more about this, from Richard and others. Then we've got the various agent frameworks. So for instance, my ex-employer, FetchAI, I built up the autonomous agent framework, which we then later forked at Valerie to create Open AEA. Then there's, since the beginning of kind of LLM's entry on the larger scene, there's these large language model specific agent frameworks. So LangChain has by far, I think, the most attention. RoboGPT, AutoGPT also fall into this bracket. Autonomous has the space as this place for decentralized autonomous agents, right? So autonomous services. But what is very exciting and sort of the 10, I don't know how many years, North Star of Valerie is to basically reach co-owned AI. And I think we share that with a lot of people in this room. And I think it's very natural, because we're at the crypto conference, to really kind of put the flag down and say, at this intersection of crypto and AI, this isn't just some sort of hype thing. This makes genuine sense for us group as builders to build towards this, and we have a general reason to build toward this, because I believe DAOs are effectively primal forms of co-owned AIs. They give us these on-chain mechanisms of basically coordination. And as a DAO becomes smarter and involves more on-chain and off-chain software programs, it is basically on a tangent to co-owned AI. So it is a very natural North Star for a DAO to become a co-owned AI. And that's at least what we believe. I'm going to kind of wrap up with a bit of a focus on the tools we offer and the ways in which we have thought we could kind of collaborate with everyone in the room here. So as I mentioned before, we have this messaging framework called the ACN, There's exciting things here to make this interoperable with other messaging frameworks like XMTP. I know Sean will talk about this later, and others. We have the Autonomous Services Framework, which basically builds on the Autonomous Agent Framework OpenAA, where you can build these autonomous services. And then recently, we've been exploring in the Gnosis ecosystem with various of the people in the room, Martin and others, this concept of AI Max. And we're very excited by this, as I think a lot of other people. And so we really want to continue pushing this and make this an open and sort of permissionless system, maybe a hyperstructure. So the areas where we can work together are basically interoperable off-chain messaging protocols for agents. We had 2 talks which already touched that a bit. We'll have more on that later. Open source tooling, where we can use LLMs to make it easier to interact with the EVM and other smart contract platforms. Building co-owned AIs, making DAOs actually autonomous, and any sort of innovations which we collectively can accelerate at this exciting intersection. And any presentation needs a meme. Someone told me in ETH Denver this year, so here it is. I hope it was insightful for you, and look forward to the discussion later.
Okay, I think you can see my screen. Let me know if you can't. All right, so today I'm going to talk a little bit about LLM agent frameworks. So I wanted to talk about the AI side because a lot of the time at AI crypto events, we end up talking about the crypto side, understandably. And I kind of see it as my job to like evangelize all of the different stuff that's going on in AI, because it's like there's really a lot, and it's a lot to keep up with. And I'd love to upskill you know, a lot of people in the crypto space about what's going on. So what are the opportunities in AI and crypto? So crypto provides the infrastructure and tooling, while you know AI provides the promise of utility and increasing adoption, for example. Crypto has been interested in agent frameworks and you know autonomous agents for a long time, and then in the AI side, like recent advances have like changed the way that we're creating flows and agents. So these are the kind of opportunities and overlaps. And as I mentioned, I'm going to talk a little bit about the advances on the AI side, and also like, you know, the abstractions, like, and all of this will lead to, you know, hopefully standards in future. So what is prompt programming? Well, the big thing that changed with prompt programming, it was enabled by these large language models, where, you know, a single model can perform multiple tasks, so they're more general. Before, we would have had to train a model for every different task. But now we can just go on to, you know, GPT-3, ask it to summarize, ask it to extract text, and it can do all of these things. That's like quite a relatively new thing. Prompt programming also uses the language model as just one component in a larger system. So then we have other building blocks, for example, like tools, memory, and some others as well. And what we can do is we can like compose chains or flows, where, you know, different steps could be like a call to a language model, or it could be an API call to a different tool, or it could like, you know, store to memory or something like that. So you can really build these like complex apps where the language model is just one component. And I heard a term I really liked. It's called like a no gradient architecture. Of course, learning used to involve gradient descent in machine learning, but now we figured out that we can actually learn without changing the weights of the model at all. So we can like, you know, include different input and output data samples in the prompt itself, and the model will learn to change its behavior based on that prompt. And this doesn't involve updating the weights at all, right? And we can even show them procedures about how to solve problems in the prompts as well. And kind of like teach models to perform new tasks and learn new skills. I'm going to go through a few of the different frameworks because I think it's really interesting to look at the state of the art and the different abstractions and the way people are trying to approach the problem. And then finally, I'm going to talk about like how we can apply these to crypto frameworks. So one of the really interesting frameworks is Llama Index. It focuses mostly on retrieval tasks. So for example, it can be used with question answering. You might have seen some demos of this on Twitter. So what happens at the different steps with Llama Index? The first step is like, let's say we want to answer questions about a document. The first thing we need to do is like get chunks from that document. So we use like some sort of chunker. Once we have the chunks, we can combine a bunch of different chunks into what's called an index. So you can see in the top right there that we've got different nodes, which are different chunks of text, and they've all been stored in a, say, a vector database or something like that. And they've been run through like an embedding model as well, so that they're not stored as text, they're actually stored as vectors. So you pass the text through the language model, and then you, at a certain layer in the language model, you extract this like this vector, which is basically like the language model's understanding of that word or representation of that word. And then that's what we store in the vector DB is this vector. Llama Index also has these things called retrievers, which can like fetch from relevant nodes, and you can like synthesize responses. And you can actually do some quite complex stuff like this. You can have like an index of indexes, and you can like have a router that routes between different indexes based on the user query. LangChain, I'm sure everyone has heard of. They focus less on the retrieval step and like working with the data, and more on the stuff that happens after. So you can build like chains of LLM calls. You can also build agents, and it has a bunch of building blocks that are kind of shown on the right. So you have the language models. You also have like memories, memory. You can store to memory. You can create agents, as I mentioned before, and it's really quite flexible. A new one that's come out is called Semantic Kernel. It's by Microsoft. I really like their abstractions, and I think they're like even better than LangChain. So the kernel is kind of like the orchestrator, whose role it is to like solve the user's query. So it's kind of like the assistant itself, or you could call it like an agent. Its role is to solve the user's query with like all of its available skills. And in the bottom right, you can see like what the collection of skills looks like. So you might have, say, a registry of skills with skill A, skill B, and then the final, the lowest level is like these functions. So a skill is like a collection of different functions that can be used to achieve a certain task. So some examples of skills are for like question answering, summarization, coding, telling a joke. It could be really anything. I think I really like the abstractions of Semantic Kernel because they overlap with this book that I read. It's called Age of Invisible Machines, a practical guide to creating a hyper-automated ecosystem of intelligent digital workers, which I think is definitely something that a lot of people in the room will want to build. Instead of the kernel, they call it like an intelligent digital worker, or an IDW. An IDW is made up of skills, and the skills are composed of microservices. So the microservices are kind of like the functions from before. And they also include like this concept of flows that isn't really in Semantic Kernel, as far as I could see. Flows are sequences of skills used to perform a task. And I gave some examples of flows in a recent like tweet thread that I did. So like find, chase, nudge, question answering, summarization. I think there's like more than 20 that they gave examples of in the book. So yeah, now I'm going to talk a little bit about OpenAEA. Of course, David covered a lot of this. Also Open Autonomy. So these are like crypto agent frameworks. So AEA stands for Autonomous Economic Agent. It focuses more so on like a single agent, which can interact with other agents, but it's really just focused on more so on single agents, whereas Open Autonomy focuses on multi-agent systems. I've just dived into the literature on multi-agent systems, which David mentioned goes back a long time. It's crazy how much is there, and like there's so many. It's such a goldmine just because like so much has been opened up with LLMs. I'm just really excited to like explore all of this, multi-agent system research with this new lens of LLMs. There's so many opportunities there, I think. So the cool thing about OpenAEA and Open Autonomy are that they have abstractions that are similar to Semantic Kernel. So for example, we have skills. And there's also other overlaps, like, for example, these finite state machines. Finite state machines are what are used to create like the functionality. And they're basically just like a graph-based version of a chain or a flow. That's kind of how I'm thinking about them. So yeah, we're actually like exploring working together with Autonomous and Valerie to basically integrate some of the ideas from like recent LLM frameworks with crypto agent frameworks. Of course, crypto agent frameworks have been in development for a long time, which is like a big advantage. But also, like these new ones, these new LLM frameworks provide a whole bunch more utility that we can apply to like a number of use cases. So this is just a slide I just wanted to put in an aside, like what is an operating system? I've been diving into the history of this a little bit as well. So an OS is made up of a few different components. For example, a file system, which is like, connects it to different data sources. a kernel, which is like the bridge between hardware and software, or like it orchestrates things, and a shell, the part that the user interacts with. So you might see a few similarities in the way that I've set up this presentation. Like, for example, Llama Index is like a new way of interacting with a file system through this, through use with large language models. And then we even saw that one of the LLM frameworks uses the concept of a kernel, which is inspired by an operating system. And then, of course, like, I didn't touch too much on what the user interface is, but that's another important aspect. Some of the things that the kernel does are on the right, like process management, memory management. This all sounds quite similar to how these LLM apps work. And an operating system provides a variety of APIs that allow them to interact with various aspects of the system. So a lot of this stuff is what we are inspired by at Algovera. And what we're trying to build with our product is basically an end-to-end solution for creating customized versions of these LLM assistants and agents. So we try to do like many different stages in the pipeline. So uploading and managing different data sources, building LLM flows, assistants and agents. All of this is with no code, by the way. Then deploy these different services. So, for example, deploying an assistant or an agent at various different interfaces. So it could be an API, or it could be, a Chrome extension, or it could be a Discord bot. And we're focusing on question answering assistants to start, but the plan is to like expand to more. So just to conclude, there's been a lot of recent breakthroughs in AI. For example, with the way that we build agents using LLMs, it's completely different. It's still early with respect to frameworks for LLM agents. So like, LangChain is so new, Llama Index is so new. And this is an advantage that crypto agent frameworks have over these new ones. They've been in development for a relatively long period of time. I really like the abstractions of the crypto agent frameworks, like OpenAEA and OpenAutonomy. But the thing is, these, and I think David touched on this, the agent frameworks haven't really happened in crypto, and I think LLMs are the piece of the puzzle that we're missing. So with LLMs, we can combine them with crypto agent frameworks. We can get the best of like crypto infrastructure and like payments and all these sorts of things, while also getting the utility and functionality that AI provides. So yeah, that's it from me. I'm not sure if we have time for questions.
No, sorry, Richard. That was really cool, but I've got to cut you off.
No problem.
I'm going to bring up Don now.
I'm going to assume yes, but I can't hear anybody. So maybe I'm a little bit of a fish out of water. So I'm from Nevermind, co-founder, CEO. We're less of a pure AI company. We're more of a data company for AI. I think everybody's conscious of the fact that we've seen a massive explosion in the AI space in the last 12 months. So we look at the world in kind of three ways. What do AIs need? They need compute, they need expertise to build them, and then they need shit piles of data. So we're hyper-focused on the last piece. So my background, just so everybody's kind of familiar, I spent basically a career in IT consulting, building out data estates for big companies like HSBC, AXA, L'Oreal, Sharp, etc. And I cut my teeth during the age of big data. So started right before big data really started to blossom, and then witnessed its evolution over time. And one of the things we witnessed were, a couple of things that seem to be being replicated.
I have to interrupt you for a second.
Yeah.
And sorry, I didn't realize that you couldn't hear me. I need you to hit present, and then I can add your slides to the stream.
Oh, okay.
Sorry, I thought I was unmuted this whole time. Okay, cool. Here's your slides. Let me get out.
Got it? Okay. You can now see. All right. So, but you guys can hear me, right? Where the hell are the comments? Okay, cool. So I'm just going to rip through this then. So yeah, one of the things that we witnessed in the big data space was like, I remember when I started, if we wanted to do really advanced analytics, and this was like 25 years ago, we needed to, we're probably going to use an appliance from one of the big compute providers. And that for like one use case would cost upwards of $10 million a year. So So it was just a crazy amount of money to spend, and therefore it didn't scale very much. But then there was the release of the white paper on MapReduce, and that led to the team at Yahoo developing Hadoop, and then that led to basically the explosion in big data. And the driver there was we moved away from these fit-for-purpose specific appliance machines and towards leveraging commodity hardware. So I think what we're probably going to witness in the future is a move away from expensive hardware and towards cheaper commoditized systems that'll help us compute. The other thing we also witnessed is, as big data became more popular, more people entered into the fray. And what that did was it increased the amount of expertise that was in the domain space. And the result of that was it drove the prices down for that expertise. The one thing that we did witness is that on the data side, while the unit cost may have gone down, that was met by an increase in the complexity of the data sets. So the actual aggregate cost of creating and maintaining the data didn't actually go down, and it likely went up for most organizations. And so that's kind of our framing for everything that we do at Nevermind. We believe that in the long run, data will prove to be the biggest rate limiter to AI advancement. So we're super focused on how do we make information and data sets more accessible, and provide outlets for the wide swath of applications and use cases that are going to leverage this new technology. From a constraint point of view, again, like I said, data will be a primary bottleneck for AI. Also, as I think we're all sort of conscious, there's this lack of transparency. There's the black box issues. There's definitely copyright infringement and IP protection problems. Getty suing Stability AI is a great example of that. And then there's also the lack of monetization, and that's where we're specifically focused at present as an organization. So one of the things that we're saying is, and kind of anticipating, is that AIs won't have bank accounts. So how are they going to transact? I think a lot of us that are on this call, or this conference will agree and are biased that these AI agents will likely transact via wallets on blockchains. So how do we enable that? So we need to address the fact that overall the UX still sucks, and this is why we created the Nevermind app, which we're going to launch in 2 weeks' time. In addition to supporting, the registration access and publishing data sets and AI services, we have come up with a novel application for NFTs. So in the course of the last 7 years or so in this space, myself and my co-founders and our team, we've built a lot of different marketplaces, and the user experience in particular for Web3 marketplaces is horrendous. If you take, for example, a DeFi data marketplace, you're a quant, you want to do back testing, you want to back test across 12 months worth of data from 5 different DeFi protocols. You're looking at like 60 confirms through MetaMask to get access to those data sets at a minimum, probably more than that, because it's probably more than 1 confirm per asset, per data set. It's just a ridiculously horrible experience. So we came up with the concept of subscription NFTs, where basically you create a wrapper for assets. They could be data sets, they could be AI agents, they could be associated services, third-party services, etc. And what you can do is set the, currently you can set the time window for which you can gain access. So we have some off-the-shelf canned windows, like 1 month, 1 year. You can set a free subscription if you want. There's also the possibility to create a bespoke subscription where you can set the time period that you want to avail access to your assets. And then you can also set the price. Initially, we'll support USDC, but we can support any ERC20 token, and we will launch on Polygon and Gnosis. But anyway, the idea here is you create basically a bucket, and that bucket's represented by an NFT that can be used to token gate access to the underlying assets that you append or stick into that bucket. And then you can control the period for which those assets are actually available. So what do you get with the app? You get an asset registry, you get access control provisioning, and you get the means to monetization. That's one of the big things that we've seen in the space so far, is sort of a lack of monetization capabilities for those that are developing AI agents specifically. So what we do see are the platform providers, the OpenAIs, the Stability AIs, et cetera, their ability to monetize and capture value from the services that they're providing as platform vendors or as service vendors. But those that are building on top lack the native means to actually start to monetize and capture the value of the services they're creating. So we created Nevermind, the Nevermind app. And this is the app itself. I think I'm probably running out of time, but I can start to show you some of the functionality. Here's where you would create your subscription, your plan. You set the description of your plan. So a novel subscription to really important data. And we'll say this is DeSci data set. Add the tag. And here are your options for the term that you want to set the plan's validity to, or the access, essentially. And you can set the price if you want. And the way that we operate, we take a 1% fee from the sale of the asset. So the publisher only has to pay for the gas fees. But if that asset is actually sold, and I'm not going to wait for this to go, but if you come back to the marketplace, you can start to see these assets. We're toying around internally. Our CTO created an Elvis assistant, which basically allows you to query or summarize Elvis songs. So actually, I'm not sure if you can see it. You probably can't. But in our Discord, if you were to go into this service, you can buy the service. I will buy it. And this will give me access. Oh, great. It failed. So I won't get access right now, but it gives you access to the API endpoint with the encrypted JWT token. And I can use that and embed it into a Discord bot. And then I can start querying that bot from Discord. And I can, type in the name of the song when I ask the bot to do an action, and it'll give me the summary. And that's, I think, all I've got for now.
Okay, Don, I have to cut you off. We've got
Yeah, no worries.
For a break so we can make sure we have time to get our next speaker up on time. But thank you for that. That's really cool. Our next presenter is Alexander Kozlov. I'm going to bring him up as soon as he's ready. Thank you all for sharing the questions. They look really good. I'm very pleased to see the depth and seriousness of what you're asking. And I'm thinking, or I'm expecting that the discussion section that we'll have at the end of this will be quite useful and interesting. So, okay, cool. I've got Alex with us. Hi, Alex. How's it going?
Doing great.
All right. Take it away.
All right. How do I share my screen, though?
You just hit present at the bottom, and I'll add it to the stream.
All right. Do you see the screen now?
Yeah.
Can somebody answer in the chat?
Yeah,
Do you
we
see the
can.
screen? Okay, cool. All right. So I'm Alex. I'm not an AI engineer. I'm not a big data science guy. I'm just an architect with experience building no-coding tools. And I'm into social dynamics in general and network science. And the problems I trying to solve is related to social networks. So the same thing, that they're black boxes, they're owned by one entity, and they're in charge of updating it. So the initial idea with this project was, it's not it's the least known project in this lineup. I started it about 2 months ago. And the idea is that to give the opportunity to open source developers to build their own algorithms and to collaborate on them together. And I wrote a piece on it. It contains all the vision and how we should basically change the way we approach the information distribution, and how important it is to have cognitive security on the personal level. So if you're interested in that, go ahead and read that. So the vision is this. The consumption should be very easy, and the algorithms should be able to run on clients or any other platform, mobile phones, backend servers, doesn't matter. It should be really easy to integrate and easy to configure. As for development of those, they should be open source driven. It's important. And there should be maximum freedom when it comes to what set of tools or frameworks you want to use. There should not be any locking. And also, it should be really modular and extensible. So storage. Since algorithms are modular, you want those modules to be permanent, or at least immutable, and always available. So one of the requirements was to make them permanent and be stored and be available all the time. Ownership. It's important so that developers have ownership in those algorithms. That way, they are more likely to be invested and excited about building them. And they should have some kind of monetary or social incentivization to do so. Yeah, so the design principles requirements for this project was simple but flexible, permanency, execution should be transparent, no black boxing, using already well-established standards and tools. Yeah, and all the tools that are available or coming up should be able to be easily integrated, and it should be future-proofed. Design, inspiration that I took for these projects were a filter pipeline. It's a design pattern in programming, NPM for its modularity and simplicity, and Hugging Face is a social element and marketplace aspect of it, which makes it working together on things more fun and more rewarding. So the elements of these systems are not a lot. It's just the first element is a module. The second one is service. It's something that wraps a module and makes it a service. And there's a registry. So let's go to the module. The module is a basic building block. It's just something that takes input and produces output. And this building block can be owned by developer X, whatever. This building block can be anything, really. It can be a neural network. It can be an inference API call. It can be a database call. It can be a local file storage. It can be anything. Because the module itself runs either JavaScript or Python. In this case, it's JavaScript at this point of the project. So everything that you can do with JavaScript, you can do with this module. Yeah, and the beauty of it, it can be run right on the client, on the browser, on the backend, anywhere where JavaScript or Python runs. Yeah, and there's also, you can use LangChain easily. Nothing stops you from doing so. I'll have a demo using LangChain in the end of this presentation. So a module can be really simple and can be really complex. Here's a schema of a module that's using 4 different modules under the hood. Some of them can be accessing data set. Some of them can be storing something, accessing memory or whatever. Another one can be an OpenAI call, and the 4th one can be producing transforming the output from the 3rd module and making more suitable for your business case. Each model contains the information needed to execute this module properly, and how to compose it with other modules, and a lot of human readable information, aka Hugging Face card module cards. And this is the example of very complex module. It can use dependencies on other executions. So this architecture allows for a lot of flexibility and a lot of rich functionality if you have any requirements to do so. There's nothing limits you to do that. Okay, I got a warning, 2 minutes left. Okay, so I'm gonna skip through and quickly show you the slides. This is how you would use it in your application. This is how you would, each module, a module can encapsulate an execution of multiple modules. So it would contain something like a configuration, how to execute them and with what parameters. This is the full metadata of the module. This is the interface and the code that executes them. This is how it would look like on the client side. If you want to select it, service wraps a module, makes it an API, and you can easily use this service from within the module in a seamless way. Registry just registered. Registers those assets on chain. The metadata is packed permanently on our Weave network using Bundle, and this metadata is linked in an NFT and given to the developer who publishes the module. Demo time, if I can make it. So on the demo, I have a dummy social network that is rendering all the modules from the system that's been published. This model was specifically developed to extract feed publications for Lens in this case. This is recommendation engine for people. This is trends. All of those are different modules pieced together in an interface. And I also managed to build easily an assistant, which takes the feed algorithm from the main page, feeds it into the LangChain, and I can answer a question on this, like how political this content is. And I can do anything on it, basically.
Okay, Alex, that's really cool. I'm glad you were able to get a little of the demo in there.
Yeah,
I'm sure people will have some questions for you at the end.
Cool.
Next up, we will bring up Robin Lehman. So let me bring you. Okay, hello, Robin. How are you?
Hey, can you hear me?
Oh, sorry. I've added your slides in an infinite window here.
Oh, 1 second.
Let me know when you're ready. Okay, cool. Looks like you're ready. Okay, cool. So I'll throw your slides up and I will step away.
Thanks. Yeah, so my name is Robin. I'm CEO and co-founder of Data Union. And so the title of the presentation is what is a data union and why should you care about it? So like we've been building on this for over 2 years now. We started when Ocean Protocol published their marketplace. And basically, I saw that you have to publish your data alone, and customers would have to find it in the endless sea of then millions of people publishing the data. And so the idea is that we create a technology which makes it possible for people to bring the data together and then leverage it together for different cases. And AI is the main case that we see with it. So how does this look like? So we have different components that we build over time. So we work a lot with mobile applications, and we put a wallet inside this mobile application. Easy for people to interact with the data, to interact with the blockchain, so they don't have to actually know about it. The wallet can also be hidden. You don't have to press accept anymore or anything. The app can do that for you. So like this is much better for the UX. And we connect this to a NoSQL database. So we want to be agnostic from different data types. And basically, the NoSQL wallet has a database has this specific property that you log in with your wallet. It's like you authenticate yourself, and then you get access to your data, and all your participations, all your contributions are connected to your wallet. So that's something which can work from a mobile app. It can work from other applications too. So and foreshadowing what comes later, it can also work from an agent. So like we could have a database where agents can start bringing data together and using that together. And what's happening with this data? So we're using then computer data to keep the data safe. To work with the data, and in a data portal, you can define what should be done with the data. So like it's kind of a marketplace. It can have algorithms. There can be competitions around algorithms, and so on and so forth. But that basically can be done by many different parties. They can have their marketplaces, their portals, and so that's basically the core technology that we're building. And so the connections here to the blockchain space are basically that all of these properties, like what is owned by you, is controlled by crypto wallets. You get a data NFT so that you can manage who gets access to it. And also like the results. So like if we train an AI with computer data, then also this becomes an NFT on the blockchain. And everybody's data and everybody who was involved can then claim from the receipts or revenue that is made from this model. Okay. So for us, it's very important to build a data lineage and a reputation. So like people can do contributions by uploading data. They can verify that data is correct. They can verify that enhancements, so like objects and data are correct, properties are correct, and then this is recognized by a third party that is correct. But still, everybody who is participating here is still owner of whatever they contributed, and we can then create this data NFTs, which then are living on the blockchain and can be then used by other parties. So like it's very important to have like these different steps. And in the future, we also see then that agents can also do the similar things. So the main components that we have are like the data NFTs for the sovereignty, a token-based protocol for the lineage, and the value share contract. So like that's a wrapper around data NFTs, so that several parties can be involved in the revenue and somehow in a certain way also the ownership of the result, but as a direct ownership or fractionizing of these NFTs would make it a security as you're earning from others. So we are going with claims and value share contracts for legal purposes. And so how does it look like today? So like we're working with several customers right now. One of them is producing a fitness device, and they have now a mobile app, so user can upload their data. Then it becomes part of a data set. And then different parties can also list algorithms on there to analyze it. And then in the end, everybody who is involved can then claim their shares into their wallet in the mobile app. And so the next frontier that we're seeing is basically now with agents. So like the paper that really impressed us there a lot was this Voyager paper around playing Minecraft and building a skill library. So like this would be something which would be ideal for the agents can build up the memory together. So like they can start also here verifying and giving reputation to certain skill libraries, to certain skills, maybe also to the curriculum or in the end, like the census that is done to evaluate if things are correct. So like all of this can be done then in a data union, and the skills can basically evolve over time, but not just by one single entity, but by multiples. And so like this helps us a lot because agents can scale up a lot, and we can do other tasks too. So like Minecraft would be the first step. The only problem I see in this is that this if it becomes fully decentralized, the AIs could run away from us. So like if we can't control this. So like in a way, many of our components are still Web 2. And maybe for this kind of experiments, that's also a good idea to do it like this, so that we could still stop them if they go haywire or like crazy or something. So the standards that we already are doing today, so like we're building on top of Ocean Protocol's data NFTs, so that's a combination out of ERC 7021 and ERC 725 and ERC 24 access control. So like there we're creating already data access control, we're creating data unions on chain. We have like the AI trainers, we have AI models, we have AI inference data NFTs. So like these all have parameters and so on, which are defined by the people who are publishing them. And we would really like to be able to interact with all of the speakers and the projects that we have here. And so we want to make sure that what we're building also makes sense. We are still iterating a lot, so it's not the end of the road or something. But yeah, that's why I'm here and want to have some discussions. How can we bring the private data to the AI, and how can we make sure that everybody is involved, gets their fair share of what comes out of this? Yeah, so that's my presentation. Thank you very much.
Cool. So I'm going to throw Sean up on the screen now. Sean, how's it going? Thanks for joining us. Ready when you are. And if you have any slides, you can hit present and I can add them to the layout.
Cool. Can I actually just like share my screen? Is that possible?
Yeah. Let me do that.
Okay, cool. I just did things through just the Notion page here, but I'm Sean Brennan. I'm the CEO and co-founder of Relay. For most of last year, we were building front ends on top of XMTP wallet messaging. And so being in the chat space, November 30th, we're like, wow, there's definitely a reason why AI would use crypto. And there's going to be a mix, basically an AI that controls and has self-custody over a wallet. And so I just wanted to talk today about some of the practical things on why we picked our stack for these AI agents, like an open stack. And then there's some theoretical things around the more like AI communication standards and some advancements in ZK-ML that could be a very interesting solution. So basically, like it steps through like the first need that I believe is for agents to need a way to do commerce. I think Don mentioned, and multiple people have talked about how agents controlling crypto and controlling wallets seems like a very natural evolution. It's unlikely they use banking APIs or using credit card payments. And so this could be one of the necessary, like the general public would need crypto in order to interact with useful agents. So first, it starts with humans needing to use crypto to pay agents, and then agents to agents can engage in commerce, negotiate. And so there'd be a way to, for an agent to check for the receipt of payment to it, which is it's more simple because you could just like watch the Etherscan API and change the agent behavior based on that. The other part of it where an agent can decide to spend crypto is, I think, more complex because what if they're wrong, right? Like they could waste the money. And so there's basically Relay is working on ways that an agent could self-custody, and I'll talk a little bit more about that later. So then the namespace, if we're on the EVM, like in Ethereum layer 2s, then ENS is human readable names. It's very easy to create subnames for a company or a person. And then, for example, like ai.metamask.eth could be the known name on different clients to message that chatbot. And that also lets you do things. They have new things around subnames where you can basically mint NFTs that give rights to subnames. And there's basically advancements in the EVM namespace that would make this even better. And then the next one is the message transport layer, where if you're on the EVM and you're using ENS, what do you use for messaging? There's a number of frameworks out there. I put my top 4 here. And since we're building on XMTP, and I think they have the greatest benefits to offer right now, and in the future, we're continuing to basically create XMTP adapters, and our agents basically can listen for messaging coming into their ENS name and then do their logic and then respond. And there's some alternatives there. But I think what's critical is that all these different agents have a way to initiate communication. If you think more sci-fi, like in the future, if an agent even is able to start conversation, say it's like in another language with like an alien, the agent could then like Google it or look it up and then know how to speak that standard that other agent is using. And so it's really like, that's a more sci-fi example, but basically I think there's going to be network effects on which messaging transport layer the agents use. And the cool thing about this is that if you use this, then your agents are immediately available on different clients, including the XMTP app, the Relay site. There's a Converse mobile app, which is great. And like there's apps on Lens. And this is also useful for human-to-human interaction, human-to-chatbot, and we believe it'll be used for agent-to-agent. And then there's basically the conclusion for this part is for commerce, names, and messaging, we have the EVM, ENS, and XMTP, and all are open protocols to build on top of. And so here's like what our site looks like when you talk to register.relays2c.eth, which is about ENS. And so you can register an ENS name. And the same thing for Uniswap, where you can talk in human language and do a DeFi transaction. Some open questions here are for the EVM. It's basically easier to check for received tokens than for the agent to decide to send tokens. For ENS, I think there's going to be a registry of agents. And so someone has to build that. There basically could be a known way for an agent to bootstrap onto the network and basically get a mapping of all different agents it can talk to. And then for XMTP, I think there's a problem with Sybil resistance right now, where it's too easy to spin up a new XMTP name with basically no cost. And so if our agents are responding to messages, it's hard to tell whether it's a message from a first-time user or from someone with 10,000 accounts spamming our bot. And literally, it's like a wallet draining attack with using OpenAI balancer. So like I think Gitcoin Passport, WorldCoin, some others are basically a way to check that it's a human or it's an agent that has some basically proof that it's not Sybil attacking you. And then more theoretical here is like, I think most of us would agree that like the internet is kind of splitting into 3 different zones: human and human, where you can gate it by proof of personhood; human and agents, which are helpful chatbots and other useful agents. And then soon there's the idea of like agents and agents communicating. And so this is both good and bad. Like it's basically a 24/7 PvP zone for agents to interact with each other. And there's a few like attack services I put 2 here. There's probably a number of more where you can either try to get the agent to reveal his prompt or reveal some private data or even the private key that it's using, or you can try to lie to the agents and basically get the agent to act in an improper manner. And then the solutions to that are, there's basically this idea of super coordination or super rationality, where if an agent can prove without a shadow of a doubt that it's only able to act in a certain way, basically constrains its possible actions to something known. And so there's some links here. I'll put this document in the chat so you guys can check out these links. But basically, there's a way through ZK proofs to prove how a machine learning model, how the output is true. And so I believe there's a way to basically show that an agent will act a certain way in regards to certain input. And so I think this is how we can get to agents cooperating and having like basically long-term positive sum games. And is the agents are able to trust each other even more than humans are able to trust other humans. And so that's pretty much it. I basically invite everyone to either review some of these links. I put some links to stay involved with Relay. We have an alpha of our like XMTP bridge. I think my CTO just published that yesterday, so it's not there yet. But I think if you're interested in your agents able to either use Ethereum tokens or communicate over XMTP, that's what we're building. So
awesome. Thank you, Sean. Really cool stuff.
Cool.
Okay.
Thank you.
Yeah, no problem. All right. So last but not least, I'll bring up Martin Kuppelman. Hi, Martin. How are you?
Hey, doing very well. Exciting
Thanks for
conference.
joining us today. Cool. If you want to throw up some slides, go ahead and do it, and I can add them to the layout for you.
Yes. Does this work?
Yeah. Okay. It's all you.
And you have, you see my slides in full screen?
Yeah. I can do that for you. Okay, cool. Your
Alright.
slides are in full screen.
Cool. Yeah, so I'm Martin from Gnosis, and I have to, kind of be honest, quite new to the AI field. So with Gnosis, we are for a long time in the blockchain field, have done all kind of things. Started to build prediction markets. We're very early to Ethereum, so we basically before ERC20 tokens existed and MetaMask. So kind of over the years, we built a bunch of Ethereum infrastructure. Maybe the most famous one is kind of the Safe. But yeah, then in the since last 2 years are doing Gnosis Chain. But well, since 2 months, got extremely excited about AI. And for me, really the eye opener was kind of those agents or AutoGPT, maybe as the most famous examples. And I think I don't need to explain it. Everyone, I assume, is aware, and there have been also references at previous talks. One thing I want to mention is kind of there is a smaller or kind of a less famous, but I think super interesting version of AutoGPT called RoboGPT, and I think it's super interesting because it's very, very clean. It's written in a very clean way, so I haven't really done productive coding in 5-6 years, but still I was able with my Python skills within very short time to kind of extend it, and this will be partially what I will be talking about. We're seeing those agents, and essentially they are able to kind of select from a list of abilities, and I think we had different words for that: services, modules, max, actions. But at the end of the day, it's simple, or it's APIs that can perform specific tasks. And to make AutoGPT really powerful, currently you have to give it, or there's a config file which at least allows you to give it 10 different API keys. So to really run it yourself, you need to, in principle, sign up with all those different services and give it enter your credit card information, and then feed your personal agent, your AutoGPT thing with those different API keys. And at the end of the day, it's really just a way to do payment. And here we come, and we think kind of for payments, we can actually use the blockchain. And I think this sentence was also said a few times during this conference. An AI agent will not have a bank account, will not have a credit card, but will very well be able to control a private key. So all those services, kind of that you can call, they can easily be wrapped behind or kind of on chain. And that is what we have tried to define, and it might look here more complex than it is. At the end, it's literally just kind of from an end user perspective, you just need to focus on the left side. So you have a MEC, an AI MEC, and it really just has more or less two functions. One is a request function where end user, and this end user can of course be something like AutoGPT, does a request with some arguments, with some data, and then, someone owns this MEC. And there can be kind of a complex backend, and we have heard that earlier. how that could look like. But at the end, well, someone can call this MEC and deliver a response. And the response could actually even do some kind of callback into another contract, but just in the simplest form, you have a request and you have a kind of deliver answer. So the vision would be, what if we don't have to give our kind of AutoGPT agent 15 different API keys, but just one private key and put $1 on it. And then it's able to, kind of to make those calls. And yeah, quite happy that we were able, with a bunch of people on the call just in the last weeks to, essentially hack that together and have that live running as a prototype. And I'm showing you here a little bit bit of code out of those, in this case, this is RoboGPT. So you can see here is a list of actions. And again, it's super amazing how simple you can add a new action. All you need to do is really just have a textual description of that action and have minimal information of kind of what input format this action does. And then kind of, the LLM does the magic of kind of running through this loop where it's trying to plan a task and essentially pick from those actions. But again, in this case, we added a new action, this draw image thing. And here again, instead of requiring a new API key, we just said, okay, for this one, we are calling this this AI MEC. And we'll look how that looks in detail. So here again, super simple, trivial example, but note I didn't explicitly said, okay, it should draw an image. I said first do research how aliens look like and draw one. And then kind of, AutoGPT does its thing. It makes a plan. Okay, it decides first to Google and find a bunch of relevant addresses of how do aliens look like in popular culture. Then it extracts information from one of them, in this case, the Guardian culture, and so on. And eventually it comes up with a description of an alien with green skin, large eyes, small body, blah, blah, blah. And in our case here, this is the thing I want to draw your attention to. At the end, it results for this draw image thing, we are now kind of using kind of an on-chain transaction. So you see here, the last three things is kind of the first is IPFS kind of object that contains this request, then the on-chain transaction, and eventually a request ID. So this transaction happened just 2 hours ago before this conference started. So again, the very top address here on the slide is essentially this key that this RoboGPT instant now holds, and that I gave, I don't know, $1, something like that. The contract it now calls was this on-chain MEC. And the call did contain a payment, and the MEC specified that it wanted to have a payment, or the MEC can specify that it needs a specific payment for a request to be valid. In this case, it's set to 1 cent. So the 1 cent payment is part of that request. And then eventually the request contains data, but not the data directly, because that doesn't scale all that well. But so instead, in this case, it would even be possible to put the data directly on chain. But in this case, the data is an IPFS or kind of an IPFS link or kind of IPFS hash, and that IPFS hash then has this specific kind of content here. And then in the next step, and this is also kind of what RoboGPT then can do, is kind of listen for the response, or listen for the response event on chain, and eventually, kind of gets this nice picture drawn. The amazing part here is that the code to do that was extremely simple to write. So this is literally all kind of I had to add. And now we can actually go a step further and go away from this model where you have a predefined list of actions. Instead, we can now start our program by querying this registry on chain, where kind of those MECs are registered, and all they need is kind of such a simple textual description of their own service. And then, you can kind of, such an agent can, while at runtime, extend its capabilities essentially, and kind of at runtime query new actions it can then use to perform its larger task. That's really kind of, I think, the vision we are, or that a bunch of us is bringing a bunch of us together, kind of to come to this stage. So short kind of note on Gnosis chain. So it's a chain, well, extremely compatible with Ethereum. It actually used to be, or Gnosis chain used to be, or was one of the first side chains for Ethereum. Initially, it was called XDAI, and a little bit, or roughly 1.5 years ago, we kind of merged tokens and kind of turned it somewhat into Gnosis chain. But in the end, it's really kind of just a chain extremely compatible to Ethereum. It also uses Ethereum consensus, but I think the thing that makes it for this project very interesting is just the very, very low transaction fees, and maybe also the fact that the base token is XDAI, so essentially just DAI bridged, or well, DAI, therefore kind of dollar bridged from mainnet Ethereum. So yeah, it's very, very easy to do a payment. And again, in this example that I showed you, well, the transaction just contained a 1 cent payment, and the transaction fees was just a fraction of that. And maybe as an outlook, that works for now quite well. But eventually we can also kind of go to layer 2s. So yeah, we hope Gnosis Chain can become a place for those AI agents. And yeah, kind of once we have this permissionless registry, yeah, we want to kind of discover those actions. We want to do the communication, the payment. We want to have maybe then things like arbitration or rating of those actions. Did I already get warnings about time?
Yeah,
so.
Martin,
Yes.
if you don't mind, I'll cut you off here because I'd like to.
For sure. For sure.
So for this next segment, we have about 15 minutes left on the agenda. And I've invited our previous speakers back to backstage area. If you'd like to join us for live discussion, I can put you up. I'm going to throw up David. We have Sean. Robin is also here. For this segment, we want to have a kind of general discussion about the things that we've talked about, but in particular, I want to request that we return to the theme of interoperability, working together, and looking for ways to build this as a community of builders working collaboratively. We all have very complex projects that are all going in different but related directions, and I think this is a great opportunity to talk through some of the challenges and also some of the opportunities for collaboration. So of course, we'll also, allow you guys to take some questions and let the discussion go in whichever direction it goes. But that's something that I would like to request that we keep in mind. So with that said, I'll stop talking and maybe I'll hand off to David. Oh, one thing I forgot.
Maybe hand off to whoever has most to say to begin with.
I should also say I'm going to drop a invite link that will let our externals join. I can have 10 people on screen at a time. So if you do follow this link and join us and you don't have anything to say, consider dropping off if we're getting close to 10. Okay.
So around interoperability, I think I just have something to posit that you guys could either agree or disagree with, but I think it starts with the message transport layer, because if two agents can't communicate with each other, then they can't be interoperable. And so I think that's kind of how we might want to think about things, where our different companies' agents, as long as they can communicate, the agent's understanding of another agent can be handled in like the process logic and the prompt and the back end. But like the first step is them communicating over a shared channel.
Yeah, totally agree. I think there was, when you were presenting, there was quite a few people actually commenting on that. Also regarding Orbis, you obviously presented XMTP. Yeah, I think we just have to work out how to connect all these things. Simple, but
yeah, my take is a little bit that kind of this some basic form of communication can actually happen on chain, or can happen. Or I think this idea of having a representation or on chain representation of an agent that you can call is quite powerful. Of course, that leads, or kind of there are limitations of that, and then you want to go beyond that, and you want to have then pure off-chain communication. But I would certainly advocate to say the composability of on-chain is quite strong. And there are many things. As soon as you want to have kind of whatever, even simple things like a multisig or kind of additional rules of how to communicate, then that's hard to replicate in pure off-chain protocols.
Yeah, and that's on the crypto side as well. Then we need to figure out, like, on the AI side, how are these agents gonna, communicate? What are the semantics of that language and stuff? So there's really a lot of work to do on both sides, I'd say.
I mean, I can also say something on the message protocol. Like, there's the transport protocol, there's the namespace, you nicely put that on, and then there's like the message protocol, like the communication protocol, for instance, HTTP, and then there's lots of others, and they need to be considered differently. Although with LLMs, you have the benefit that you don't necessarily need to worry too much about bridging those. So it's mostly about, I've got like an agent that's assumed for the moment for simplicity is represented by a wallet. Let's assume it's basically the curve Ethereum uses. So you end up having this job of mapping that wallet address to some location in the network where this wallet is actually receiving messages. And like, yeah, I mean, XMTP does that, Wallet Connect, like lots of them do that. I think some of them are more or less decentralized. And then like what Martin was saying, there's these big questions around how do you incorporate multisigs into the system in a meaningful way. And so I think like most practically, what would be helpful is to just sort of asynchronously connect and like in a shared space, like an OceanDoc or whatever, and throw together these design consideration, because I think everyone brings insights into different parts of this problem and like technologies they're already working with. And then we can figure out where the pain points are. And I'm sure most of this is solved in some form or another already. We just need to connect it.
I can ask a question that's come in via text. I'll throw it to the panel. Jonas would like to know, what role will solutions like CCIP from Chainlink play in the future?
I can't say much on that. Anyone able to comment on that?
Like CCIP is cross-chain messaging in a sense, I think. So either agents could be the source of a message into CCIP, which would then probably go to a smart contract, or agents could be listening to certain output from a smart contract through CCIP. I'm not super familiar with that, but I think like as you talk to a bot, one thing I've been thinking about is how outside of the user input to the bot, so like the user chat, the bot can be basically looking at other data sources, say for the receipt of a token, or basically any sort of API could change the bot's behavior from one state to another. And so the CCIP data, like if it's watching a smart contract, the bot could react to changes in the smart contract, which seems useful.
I'd actually love to. Oh, sorry. Go ahead, Martin.
I'm just kind of saying one more kind of argument for experimenting with somewhat putting more of the messaging on chain is this idea of callbacks, or kind of the idea that a response can actually be a smart contract call back into another agent that then might trigger the next action. So kind of just this idea, or I mean, I feel like kind of that unlocks quite a bit of composability.
I have another question from Mark Hampton. I think some of you may have a take on. What do you think about this one? Won't AI in the near future enable heterogeneous protocols for communication? I think probably.
Not sure I fully get the framing of the question, so maybe I'm off. But like, yeah, I think it will be totally heterogeneous, and I think like basically with LLMs at the communicate, like basically, if you go back in multi-agent system literature, then they will have like all these very structured messaging protocols which sit on top of the transport, right? So transport is about getting the message from A to B somewhere in the network. And let's assume we're now in this place where the agent process is located. And now you're gonna have to interpret the message. There's been like FIPA protocol, which was like, one of the earlier ones, and just been like tons of different protocols, very structured. I think with LLMs, a lot of this basically goes away, I would assume. And you basically just, as long as it's message-based communication, the system at the other end can figure out what the heck this is. You already see this with JSON. If you just give it to, like any form of data, if you give it to an LLM, it's pretty confident in figuring it out. Obviously, there's a lot of edge cases and a lot of work to be done, but I don't think we'll go back to something like super structured on this level. On the transport level, yes. Also on the transport level, just want to tack one thing on. I think like it's going to have to be as open as possible. Like anyone trying to place their token there and kind of gate it in some complicated way, I don't think that's going to happen. Basically, at the end of the day, you just need to map an address to a network location. And there's some work to be done to maintain these mappings as like DHTs, for instance, like, academia style or otherwise, but that's about it. And then you're kind of talking to the other entity.
This one's got a couple of clauses, so you'll have to follow along with me, or maybe you can read it for yourself in the chat. But Daniel Ong has a thought here. Is there a way to create a GPU overlay network for Ethereum or Gnosis validators? Nowadays, Ethereum and Gnosis validators don't require a GPU, yet there's still a lot of validators who are used to running GPUs from the proof of work days. He then says this could be an opt-in network like EigenLayer, and people pay to use the GPU overlay network for inference or training. And he wonders if there's interesting applications where the settlement and payments layers are tightly coupled with the compute networks. Does anybody see anything like that? Maybe not, but definitely seems plausible. But yeah, like I think as David has kind of alluded to with a lot of this stuff, there's many things that are possible. It's just we're still very, very early. So it can be hard to take an idea like that and say, will someone build something like that? Maybe. There's nothing stopping them other than, you know, money, time, and attention, right?
So I'll have one question here for Richard, because my understanding would be that training generally, like, you're already like orders of magnitude away from what can happen in a centralized facility. So you're not playing like massive backup catch up. Whereas I think like fine tuning is where it's at, but like Richard is way more versed in this area. So tell me more.
Yeah, I think like a lot of the gradient free stuff doesn't require any training at all. So like that's where I'm hoping to start with a lot of these decentralized compute infrastructures. Like we're exploring with Giza Tech to create like a prompt engineering workflow or assistant that will hopefully deploy on chain. I think that would be super cool, and that will just like make API calls to the language model, which is the compute intensive part, I guess. Yeah, then like I'm not sure if anyone saw the QLoRa technique just came out this week, but it's basically like a really easy way of fine tuning a pre-trained language model. I think someone said that like you'll be able to like fine tune on like a smartphone while it like plugs in into the wall at night, and that you'll be able to fine tune. So that's kind of the stage that we're getting to, and we're going to get to with these language models. So yeah, still like, you know, training the language model the first time is going to require a ton of compute, but like at least after it's trained, we'll be able to like fine tune it for specific applications, or maybe even run these like applications on top of the models. By the way, I got to jump. It's been a real pleasure, and hopefully we can do this again soon. It's been great to see everyone come together. So really enjoyed. Thanks everyone.
Thanks a lot, Richard. It's great to have you.
Bye-bye.
Yeah, so we are coming up to the end of the time that we allotted for group discussion. We can keep going. You're free to continue the discussion if you'd like, but if you've got other commitments, feel free to jump off now, because this is technically the end of our time. With that being said, I'll also use this as an opportunity to thank all of you for sharing your time, energy, attention, expertise with us. It greatly exceeded my expectations, which were already high. So thank you for that. And thank you to everybody who attended. We've got a ton of questions that I am saving all of these, and so maybe I'll throw them to any of the panelists that want to stick on in the future. But I want to thank everybody for coming together to contribute both sides of this little project that we have here, the presenters who are sharing their time and expertise with you all, and then our audience, because if they were speaking to an empty room, there's really no point in this. So I want to thank everybody for sharing this event with their network. We definitely wouldn't have had such good attendance without you letting the people that pay attention to you know that you're going to be here. So yeah, I just want to thank everybody for contributing to the community-driven project. It's really nice to see, and this is how you grow big things, is with these small first steps. So thank you all very much. For those of you who do want to stay on, we had an interesting question from Jonas about Ethereum-specific training data for LLM fine-tuning, and how would you get that going? That's an interesting question. I think it would be interesting to know why you would need it to be Ethereum specific. If you have I mean, maybe I'll let somebody with more technical expertise take it, but if you have a good connection to, if you have a good connection between the two, does it really matter if the training data is Ethereum specific as long as it works?
Yeah, what's the goal with the Ethereum specific data? What should the agent later do? Should he trade for you, or like what do you want to do? What's the goal? Should he do MEV or something? I don't know, like that's always depends. If you want an agent, what is the goal in the end with the data for AI?
So I think like I mean, by no means are we particularly well placed to answer this question yet, but like the MEC project, which was presented by Martin and which I referenced in my presentation, could be, well, we're currently working on a use case where we extend that so that as part of this callback, which Martin was referring to, you don't just get delivered back the prompt result, let's say. You can also have an on-chain execution of something else. So you get your delivery of your data blob, which lives off-chain, plus maybe you execute a transfer or an EVM transaction of a different kind, like a swap. And I think there's a lot of projects who, for obvious reasons, looking at going from natural language to transaction execution. And yeah, I guess we need like some sort of place where these pairs accrue, i.e. the prompt and the actual transaction data. And if I get that question right, that's what they're sort of on about. And so if you had like a place where a lot of these pairs live, then you could start using that to fine tune with one of the many methods which are being explored. Meher, are you gonna comment on that?
No, I have a different question I'd like to pose.
Okay. Robin, did you want to add something to this? Otherwise, we go to Meher's questions.
No, it's fine for me. It's okay.
Okay.
Yep.
So my question is regarding the autonomous view of, building these DAOs essentially, which are like, agents that are kind of co-owned on the network. For a DAO to be truly autonomous, my sense is that an agent, we need to have some kind of agent that can self-stabilize its own execution. Meaning, ultimately, when you think of an agent, it is some kind of daemon that is running on a Linux machine. It has a certain set of computational resources, and it can have errors in its logs. And some engineer is coming and fixing those errors and giving more computational resources to this agent based on the utilization of that agent. So there's always a human that's keeping that agent running. Is there any design or project that would make a self-stabilizing agent, meaning an agent that can analyze its own logs and fix its own issues and thus keep running autonomously?
Yeah, I think it's a great question. I think a lot of people, I mean, in a small sense, a lot of people are experimenting with this. So if you look at like people using basically things like RoboGPT, AutoGPT, LangChain to basically put the interpreter in the loop, and then they effectively have the program try to converge on like some useful actual program, which they're trying to then execute in some context, like subprogram. So I think basically the thing to do is just keep watching what happens. So that's how we look at it. Like you need for the DAO, you need a substrate where they can own off-chain infrastructure. And that could be a roll-up, or that could like where lots of people write two transactions, or that could be an autonomous system that doesn't necessarily receive transactions, but kind of generates them by itself and then kind of acts upon the underlying chains. We're taking that second approach, and I think both of them are super valid, and both of them will come together. And then like you just basically wait and see what all this amazing ecosystem is doing in order to get us closer to this kind of truly autonomous system in a sense. And I mean, then you're, like, I guess the question is at which point do you bridge over into some form of super intelligence? And I guess then we're kind of overlapping with a lot of these other questions which are being asked more in the sort of traditional AI space. And I don't pretend that I know anything there. I think a lot of these things are not crypto questions. They're basically just like AI questions, which then will apply themselves to the space as well. I think where the crypto question comes in is how do I own my off-chain system in a decentralized or verifiable way? And that's basically roll-up ZKML and the kind of autonomous type systems. Even if you have ZK, you will still need data to come from various places, and you will probably want a node system, which kind of takes that, because the Oracle problem will always exist. Like if I need to read data from multiple places, my ZK algorithm doesn't help me with that, because ultimately it's about the source of that data, right? So yeah, that's kind of what I can say about this. Should we wrap up?
Yeah, let's call it. So that'll be the end. I actually have another call to get on. So
right. Sorry, Thomas.
I'll have to call it there. But yeah, thank you, Meher. I appreciate your
nice meeting you. Bye.
Nice meeting you. Bye.